All right, ladies and gentlemen, we are going to start Unit 3, and the first topic that we're going to discuss in this unit is slope. So we're going to interpret slope. Let's look at question number 1. If you leave home and walk in a given direction at a steady pace, your distance, which is measured in d feet, from home is directly proportional to the time, which is measured in x minutes, that you walk. You can use a table and a graph to represent this proportional relationship. Proportional relationships is not something new that you have learned. You learned it in 7th grade last year. So let's fill in our information right here. If this is a proportional relationship and it's going up, in 1 minute the person walked 250 feet, in 2 minutes they walked 500 feet. So it's clear that they're walking an additional 250 feet every hour, or excuse me, every minute. So this should be 750, right? And then this should be 1,000, and then this should be 1,250, okay? So then, what is the constant of proportionality? Well, you guys do this all the time. You figure out that the person is walking 250 feet every minute. So 250 feet in 1 minute. So the constant of proportionality is 250 feet per minute. Okay, now we could have done it using this data right here. We could have taken 750 and divided that by 3, and we still would have gotten 250 feet per minute. All right, so now I need to graph this information that's given in the chart. First of all, I need to identify what is my independent variable and what is my dependent variable. So go ahead and think about which one is which, and then come back to me when you're ready to go. Hopefully you determine that the time in minutes is your independent variable and that the distance is your dependent variable. So we're going to call this graph right here distance versus time. Okay. And then down here, we're going to label this right here our time. And our time is being measured in minutes. Okay, and then over here, we're going to label this piece right here our distance, and the distance is measured in feet. Okay, and so what I'm going to do now is I'm going to graph out my information. So time in minutes, I can just go up by a minute for each interval. Okay, and then I think I'm going to go by 250 for my feet. So every block will represent 250 feet. So I will put 250 here, 500, 750. It's really up to you how you guys want to label it, as long as you include all of your numbers. So I'm going to say that this is 1,500 right here, and that this is 2,000, so on and so forth. And I know that after 0 minutes, I've gone 0 feet. Okay, after 1 minute, I've gone 250 feet, 2 minutes is 500 feet, so on and so forth. And you guys have learned that the equation for this line, remember this y equals kx right here, and in this example, our constant of proportionality is 250, so you would say y equals 250x. Now notice there's nothing added on here, it's plus 0. We're going to be talking about this in the future. But this right here, this y-intercept is going to be part of our equation here. We're going to add that on into our equation in the next couple of days. So question D says, using rise over run, find the slope of the line. Well, the rise is how much it went up by, the run is how much it went over by. So for example, if I wanted to start here and end here, I would figure out how much the rise is. And you need to make a triangle in order for this to work for you, a right triangle. So the rise, it went up by 1,000 feet. So my rise is 1,000 feet. Okay, and then the run, it went over by 4 minutes. So now I can just divide the information and I get 250 feet per minute. And then the nice thing about this is no matter what I use, I'll always get the same constant of proportionality because it is the constant of proportionality. It's constant, it doesn't change. I could have started here and I can end at a different spot or the same spot, it really doesn't matter. And then my rise right here is 500, right, feet. My run is 2 minutes. So my answer here is still going to give me 250 feet per minute. So just so that you guys know, slope and constant of proportionality are very similar, except the constant of proportionality means you're always starting at 0. Your y-intercept is 0. With slope, it means your y-intercept could be anything you want it to be, but it's always going to be the rise over the run. How much it went up by, how much it went over by. Question E, is the relationship linear, quadratic, or exponential? Hopefully you know which of the three this is. Circle the answer that you think it should be and then come back to me. Okay, hopefully you said that the answer is that it is linear because it makes a line, all right? So a function is linear if the rate of change or the slope is constant. It never changes, and that's why it's called a constant of proportionality. So right here, no matter where I start and where I end, when I do rise over run, I always get 250 feet per minute if I reduce it, no matter what. And that's really important for you to understand about slope. All right, so we're going to skip the slope formula for right now, and let's look at question number 2. Question number 2 says the graphs give information about a penguin's number of heartbeats over time in minutes during normal resting and just before diving. So we've got during normal resting and just before diving. When is the penguin's heart rate greater, during normal resting or just before diving? So to figure out the heart rate, we just have to figure out how many beats per minute the penguin's heart is beating at. So right here we know that it took, just like we always do, 150 beats in 2 minutes, but it's really because the rise was 150 beats and the run was 2 minutes. So when you divide that information out, you get 75 beats per minute. Okay? And then over here, I'm going to do the same thing. You could divide 400 by 2 because it's a proportional relationship. It starts at 0. But I want you guys to get used to now doing rise over run because it won't always start at 0. So I'm going to do the rise over the run. And here the rise is 400 beats. And it took 2 minutes. So the answer is 200 beats per minute. Okay? And the question is asking, is the heart rate higher at normal resting or just before diving? So hopefully you understand that the heart rate is higher before diving. So you would say the penguin's heart rate is higher just before diving. Okay, so now let's go on to the next thing. When will the slope of a line be positive? Well, the slope of a line will be positive when the line is going up, right? So it would look like this. Sorry, let me just do that. So it would look like this. This is a positive slope. Now, let's talk about the rise over the run. So the rise is positive, the run is positive. So in this example, you have a positive slope, right? This is still positive. Let's look at it a different way. What if I went backwards? The rise is negative, the run is negative. So in order for the slope of the line to be positive, the rise and the run need to be the same sign. Okay. So when will the slope of a line be negative? Well, same thing, I'm going to draw it out, right? So if I were to go from here to here, this has a negative rise, and this has a positive run, right? So the signs are different. See how they're not the same? Let's try it the other way. Let's go backwards. So here, the rise is positive, the run is negative, right? So in order to have a negative slope, the rise and the run have opposite signs. All right. Okay, so let's look at page 5 of our notes, and let's do what the directions say to do. Find the slope of each line. Notice how in this example, the first example that we have here, it doesn't start at 0, 0 anymore. So what we want to do is we want to choose a starting point and an ending point and do the rise over the run. Now, when you choose a starting point and an ending point, I strongly suggest you use a point that has integer coordinates. So for example, I would choose this point right here because I know exactly what this coordinate is. It's 2, 1. I know exactly what the point is. I don't suggest you start here because now you have to approximate what this point is, and that's not going to be helpful to you, okay? So here's the first point. You can choose any ending point you want. So I could choose this as my ending point. I could choose this one. Just make sure you choose one that has integer coefficients, or integer coordinates, excuse me. So let's figure this out. This one right here, the rise, it went up by 2. And the run, it went over by 1. So we're going to say, by the way, just so you know, the letter for slope is m. So we're going to say the rise over the run is equal to 2 over 1, which is positive 2, okay? What if instead I didn't use those numbers? What if I used this point right here, and I went from this point to this point instead? Well, if I were to do it that way, then the rise would have been 4, and the run would have been 2. So I get 4 over 2, which is still 2. I still get the same answer, okay? What if instead I decided to start here and end here? So that means that the rise, it went down by 2. The run, it went to the left 1, so I get a positive 2. Okay? Regardless of where you start and where you end, as long as you count carefully and you are careful of the directions you're going, you'll get the same answer. Okay? So let's try this next one. I'm going to use this as my starting point and this is my ending point. So I want to do rise over run. So then if I were to do this right here, the rise, it's going down by 3. So this is a negative 3, and it's going to the right by 4. So I get negative 3 over positive 4, right? Or if I wanted to, I could say that it was going up by 3 and to the left by 4. Your choice. So you'd get 3 over negative 4. It doesn't matter how you do it. Regardless of how you do it, you always get a negative 3/4 as your answer. Okay? And this should make sense to you because the line is going down, so it should be a negative line, or negative slope. This line is going up, so the slope should be positive. So my answer is negative 3/4. Okay? All right, let's take a look at the next one. How much is it going up by? How much is it going over by? Well, it's not going up at all. So the rise is 0. And the run is whatever you want it to be. It went over, you could say it went over 1. You could say it went over 1, 2, 3, 4. It doesn't matter. 0 divided by 4 is 0. 0 divided by anything is 0. It should make sense to you that this is a slope of 0 because it's not going up and it's not going down. It's flat. It's horizontal. It's constant. Okay? And then the last one is the tricky one. So what's the rise? Well, the rise, if I start here and I go to here, I would say it went up by 1, 2, 3, 4. So the rise is 4, and then the run, it didn't go over at all. So I get 4 divided by 0. Now, if I try to divide 4 into 0 pieces, it means I'm going to take 4 things and all of a sudden make them nothing by division, which is impossible. There's no possible way you can divide 4 into 0 pieces. So we call that an undefined number. Try it in your calculator. Try to divide 4 by 0 in your calculator. You're going to end up getting an error in your calculator, or it will tell you that the answer is undefined. All right, I want to revisit the first question on the top left part of page 5 of your notes, because this is really going to help you out. On this assignment, or on this page right here, remember we did the rise over run and we figured out that it was going up by 2 and over by 1, so the slope was 2, okay? But what I want to do now is I want to do it using coordinates. I want you to see where these numbers are coming from. So here we have the rise was 2. Let's see where we can get that number from. First of all, let's figure out what this coordinate is. You know what, actually let's use this coordinate right here. So this coordinate right here is 1, 2, 3, 1, 2, 3. So it's 3, 3, right? And then this coordinate right here is 4, 5. Okay, so the rise, how much did it go up by? Well, we know it went up by 2, but what can I do with the 5 and the 3 to figure out that it went up by 2? I can subtract them. That's how I figure out how much the rise is. The change in the y is the rise, okay? So I'm going to say this is 5 minus 3, and then I would do the same thing for my denominator, or for my run. So my run, it went over 1, but what could I do with the 4 and the 3 to figure that out? I can just subtract them. So that's how you get 2 over 1, which is 2, okay? So if you're not given a graph, you can subtract your coordinates to figure out what your answer is. Now, before we move on, I want you guys to understand that this right here is going to be called x1. And the reason why this is called x1 is because it's your x in your first coordinate, okay? And then this 3 right here is called y1 because it's your y in your first coordinate. Here, this is called x2 because it's your x in your second coordinate. This is called y2 because it's your y in your second coordinate. So if you guys notice right here, this 5 is really just y2, right? And this 3 right here came from this y right here, so it's y1. And then this 4 right here is your x2, and this 3 right here was your x1. Okay, and that's the formula for slope. So I want you guys to go back to page 4 of your notes, and we are going to fill in the formula for slope. So the slope is literally what we just figured out. It's going to be y2, and make sure the 2 is below. It's a subscript, not a square. So it's y2 minus y1 all over x2 minus x1. Okay, but sometimes you'll see it as rise over run, and other times you'll see it as the change in y over the change in x. Now this triangle right here is a delta symbol. It's a Greek letter, so you would say delta y over delta x, but delta means the change in y, which should make sense to you because how much it goes up by is how much y changes by, and to figure out how much y changes by, you have to subtract your y values, and the same thing applies to the x values, okay? All right, number 6 says to determine the slope of the line that passes through 2, -5 and 7, -10. So I'm going to use my slope formula, which I know is y2 minus y1 over x2 minus x1. Once I know my slope formula, the rest is easy. I just plug in my information. So this 2 right here is my first x value, so I'm going to call this x1. This -5 is my first y value, so I'm going to call it y1. This 7 is my second x value, so I'm going to call it x2. And this -10 is my second y value, so I'm going to call it y2. So what I'm going to do is I'm just going to plug in my information right here. Well, y2 is -10, right? And I'm going to subtract my y1, which is -5. All right, so it's -10 minus -5. And then in my denominator, I'm going to do x2, which is 7, and I'm going to subtract 2. Okay, so then these turn into a positive, right? So you end up getting -5 over +5, so your slope is -1. So the rise over run means it's going down 1 for every time it goes over 1. It's -1 over 1. All right, please read through number 7 and just get it set up for me, please. You don't have to do the actual calculations, but I want you to get it set up with all the numbers plugged in so you can get to this point right here in question number 7. Pause and then come back to me when you're ready to go. Okay, so hopefully you recognize that y2 is this 9, and y1 is this 7, and that x2 is this -5, and x1 is this -5. So then when you subtract 9 minus 7, you end up getting 2, right? And then these these negative signs, turn into a positive, so you get -5 plus 5, which is 0. I'm trying to divide 2 into 0 pieces, which is impossible, which means that this is going to be an undefined slope. And if you remember before, we had a graph that had an undefined slope. It was a vertical line. The line went straight up and down. It did not go diagonally, right? So if I were to do a rough sketch of this, you don't have to graph this out. I'm just going to show you approximately where these points are. So -5, 7 would be to the left 5 and up 7, and -5, 9 would be to the left 5 and up 9. Connected together, it really does make a vertical line. So every vertical line will have an undefined slope. All right, I want you to go through and try question number 8. See how you do. Pause and come back to me when you're ready to go. Okay, please take a look at the work that I have for this question. If you need to pause to look back at what I did for my work, please make sure you do so and make sure you understand everything that's going on here. All right, so now you get a slope of 0. Now we want to talk about what this line is going to look like, because every line that has a slope of 0 will look similar to each other. So if you remember in the previous example when we had a slope of 0, we had a horizontal line. It went straight left to right. So let's graph out our points. Let's just do a rough sketch. Again, you don't have to graph this out, but I just want you to see where this comes from. So negative 7, 8 means I go to the left 7 and up 8. And then negative 9, 8 means I go to the left 9 and up 8. And if I were to connect those two together, I would have a horizontal line, okay? All right, so now the next question's a little trickier. Please pay close attention to this, okay? Determine the value of r so that the line that passes through 5, 7 and 9r has a slope of negative 2. So in this example, I need to use my slope formula again. M equals y2 minus y1 over x2 minus x1, okay? Now what number am I going to plug in for y2? Well, it's r. It's unknown, so I'm going to leave it as r. So I'm going to say r minus y1 is 7, right? Because this is your first y value. Over x2 would be 9, and x1 would be 5. Now, I have a variable here, which means I can't have a variable here because I don't know how to solve equations with two variables yet. So what information is given to me? Well, I know the slope is negative 2, so I have to fill in that m is negative 2 down there, okay? Hopefully that makes sense to you. So now all I have to do is just go through and solve this. So I end up getting negative 2 equals r minus 7 all over 4. Your fractions, get rid of them immediately. Multiply both sides by 4. You end up getting negative 8 equals r minus 7, okay? Now all I have to do is add 7 to both sides, so I end up getting negative 1 equals r. So the value of r that will give us a slope of negative 2 is negative 1. All right, that's the lesson. Make sure you come to me with any questions that you might have. Have a good day.